So we're going to pick up with 22. Somehow the last video cut me off. And I got it worked down using the quadratic formula, -10 plus or minus the square root of 160 over 6. And remember, our directions are to round to the nearest hundredth. So we're just going to type that into the calculator. -10 plus the square root of 160. And what I like to do is calculate the numerator, then divide by the denominator. And so that gives me one solution of 0.44 hundredths. Then I'm going to calculate -10 minus the square root of 160. Hit enter and then divide by the denominator. So that gives me my second solution is -3.77 hundredths. Number 23. The parabola y equals 1/2 x squared plus 2x minus 3 is shown graphed. Algebraically, find the value of the positive 0 of this function. Express your answer to the nearest tenth. So we're looking for this solution right here. If you notice, it's a little bit greater than 1, but we want to find as close as we can to the nearest tenth. We could see if we could factor this. 1/2 times 3 gives us 1.5, so that's not going to be factorable. And I should have realized that if we're rounding to the nearest tenth, then they're not going to be numbers that we can factor. So let's use the quadratic formula again. -b plus or minus the square root of b squared minus 4ac all over 2a. This is already in standard form for us. So we've got -2 plus or minus the square root of b squared minus 4ac divided by 2a. We're going to work underneath the radical first. So that gives me 2 squared minus 4 times 1/2, which is 0.5, a little bit easier to put in the calculator, times -3. That gives us 10. So we have -2 plus or minus the square root of 10, all divided by the denominator, and that's just half of 2, which is 1. Well, we don't even need a denominator. We can just get rid of the fraction bar. And they want the positive form. So let's see. If I do -2 plus square root of 10, that gives me 1.16. So that would be my positive solution, my positive 0. It actually said round to the nearest tenth, so I rounded this incorrectly. This actually needs to be 1.2. 1.2. I rounded that to the nearest hundredth. 24. Evan graphs the parabola y equals x squared plus 4x plus 7 and finds that it has no x-intercepts. Explain how you can verify Evan's result algebraically by solving for the zeros of this function. All right, so again, if we are trying to prove the solutions, we can just use the discriminant of the quadratic formula, b squared minus 4ac. Remember, if this is greater than 1, actually greater than 0, then you're going to have two solutions. If this discriminant is less than 0, which means that it'll be a negative number, you will have no solutions, no x-intercepts, which I think that's going to be the case here. If I have exactly one solution, that means this discriminant will equal 0. So I'm just going to use the discriminant. I'm not going to use the entire quadratic equation. So 4 squared minus 4ac. 4 squared is 16. 4 times 7 is 28. And if you notice, I'm already coming up with a negative number. So 16 minus 28 really doesn't matter, negative 12. So there it proves by the discriminant that I have no solutions, which means I have no x-intercepts. So that's just a way you can verify your solutions. 25, last problem. Consider the function cubed root of x plus 2 minus 1. Graph the function on the x-axis to the right. Over what interval is f of x greater than 0? All right, we can come up with some table of values. We could also use our graphing calculator. It says that, it doesn't really say that we can't. So we're taking the cubed root. Remember earlier we did the cubed root of 8, which gives us 2. So what can I add to 2 to give me 8? So I'm going to use 6 here. Plug in 6. 6 plus 2 gives me 8. The cubed root of 8 is 2. 2 take away 1 is 1. So that's one solution that we have there. You can graph it on your graphing calculator. And the cubed root is listed down there. Number 4. It might be a different number on your calculator, but it's under math. The cubed root of x plus 2 minus 1 is outside of your cubed root. So that's what it looks like. Let's get some table of values to help us graph this. So we plugged in 6 and that gave us 1. So we got that right. We've got negative 1 and 0. We've got negative 2, negative 1. Negative 3, negative 2. Let's get some positive numbers. 6 and 1 we got. And that looks like it's little, so we could use we'll just use these numbers right here. 6 and 1. 1, 2, 3, 4, 5, 6. Positive 1. Negative 1 and 0. Negative 2 and negative 1. Negative 3 and negative 2. Let's go back to my table here. And let's see. So negative 4, it looks like it's starting to, trying to just copy that graph over there. The best that I could. Over what interval is the function of x greater than 0? So we notice this point right here at negative 1, it is 0. So anything that is so if we consider this right here, at negative 1 it is 0. So anything that is greater than negative 1, this function is greater than 0. So you can see this part right here is greater than 0, where x is greater than negative 1.